Welcome to True Projects. In this video, we are going to explain about a project titled An Integrated Machine Learning Framework for Effective Prediction of Cardiovascular Diseases. The project aims to tackle the critical challenge of precise diagnosis and prediction of cardiovascular condition. The disease rank among the leading cause of global mortality, necessitating the more effective diagnostic tool to combat their impact on healthcare system worldwide. This initiative proposes a comprehensive framework called Machine Learning Based Cardiovascular Disease Diagnosis that harnesses the advanced machine learning technique to achieve high accurate prediction. The framework comprises several stages including handling missing data, data imbalance, selecting relevant features, and employing the different machine learning techniques. The framework aims to optimize the prediction accuracy of cardiovascular diseases. Through validation with benchmark dataset and comparative analysis against the existing approach, the project seeks to demonstrate the superiority and reliability of this project as an innovative tool for early diagnosis and effective management of cardiovascular conditions. Cardiovascular disease, known for their significant global mortality rate, have become increasingly widespread, placing strain on healthcare system worldwide. These conditions are influenced by various factors including high blood pressure, family history, stress, age, gender, and many more. While researchers have proposed different diagnostic approaches to detect these diseases early, there is a crucial need for improved accuracy due to their critical nature and life-threatening risk. To address this challenge, this project introduced a novel framework designed to achieve precise and effective prediction of cardiovascular disease. The framework employs mean replacement to address missing values and utilize the synthetic minority oversampling technique to handle the data imbalance. Additionally, the feature importance is applied to the follow-up techniques like of logistic regression, k-nearest neighbor, decision tree, and of many more for improving the accuracy. And these are the following requirements that are needed to build this project. Software requirement: Python IDE with version of 3.7 or Anaconda with version of 3.7 or Jupyter or Google Colab. Hardware requirements are operating system as Windows or Linux, processor of minimum Intel i3, RAM of minimum 4 GB, hard disk of minimum 250 GB. And to know the flow of the project, these are the steps we need to discuss. The first one is importing the libraries. In this step, the necessary Python libraries are imported to support various functionalities throughout the project. Commonly used libraries include data handling of pandas, NumPy for numerical operations, matplotlib and cburn for data visualization, sklearn for machine learning algorithm, and Flask for creating the web interface and others. And the second one is exploring the dataset. The dataset containing the information about the individuals, including the attributes like name, age, and possibly the other relevant features, is explored. This step involves gaining the insight into the data, checking for missing value, and understanding the distribution of each attribute. And the third one is data processing. Data processing involves preparing the dataset for analysis. This includes handling the missing value, converting the categorical variables to numerical form, and dealing with outliers. Data processing ensures that the data is suitable format for training and the testing of machine learning model. And the fourth one is splitting the data to the training and testing. The dataset is divided into the two subsets, the training set and the testing set. The training set is used to train the machine learning model, enabling them to learn the pattern and relationship in the data. The test set is kept separate and is used to evaluate the model performance on unseen data, providing an estimate of its accuracy on real-world scenario. And the fifth one is building the model. Several machine learning algorithms are employed to create the predictive model. The first one is KNN. KNN stands for K nearest neighbor is a simple and effective classification algorithm that assigns a new data point to the class of its K nearest neighbor based on the distance matrix. And the second one is logistic regression. Logistic regression is a widely used classification algorithm that models the probability of an instance belonging to a particular class using a logistic function. And the third one is decision tree. Decision tree is a tree-like model that splits the data into subsets based on the attribute values, leading to the hierarchy of the decision rules to make the prediction. And the fourth one is ensemble. Ensemble random forest classifier is an ensemble learning technique that combines the multiple decision tree to improve the prediction accuracy and reduce the overfitting. And the sixth one is training the model. Here, the machine learning models are trained on the training set where they learn from the input feature and the corresponding target value to make the accurate prediction. And the seventh one is user gives the input. A user-friendly web interface is created using the Flask to allow the user to give the input data for prediction. The interface prompts the user to provide their relevant information that to process it. And the next step is the given input is pre-processed for prediction. The user's input data is pre-processed in the same manner as of the training data. This step involves encoding the categorical variable, handling the missing value, and ensuring the data is compatible with the trained model. And the ninth step is trained model is used for prediction. The pre-processed user input is fed into the trained machine learning model. Each model predicts the target label or class based on the provided input data. And the last one is final outcome is displayed. The predictions from all models are collected and the final outcome is displayed to the user through the Flask web interface. The result indicates the prediction for each algorithm and include the most likely class for the user based on the input data. The execution of the project. To execute the project, first we need to open the code folder. This is the code folder containing the different files within it. The dataset folder containing of the dataset that we use it for this project, and the static folder containing of the different folders within it like of CSS, JavaScript, Bootstrap and images. And the template folder contains the HTML documents within it like of about, home, index, result, sign in and sign up pages. And this is a Jupyter source file. Here likely contains the combination of code, graph and output all in one place. It allows the user to write and execute the code in individual cell, making it a popular choice for the data science. And app is a Python file likely contains the information related to the front-end logic. It includes the code written in Python that handles the server-side operation such as processing the user request, interacting with the database, and generating the dynamic content that to be rendered in the HTML template. And the model is a file containing the algorithm's information that is loaded at the time of execution of the project, and it performs a certain task like of predicting the new data. And sign up is a DB file appear to be the database file used to store the information of the user. And to execute the project, we build the Flask framework as a front end and the overall code that will present in the Jupyter's notebook file in the form of graphs, code and output all in one place. For the execution, first we need to copy this address of the code folder and then open the Anaconda prompt. Here first we need to change the directory of the disk location because of the folder is present in fdisk, and then write a command of cd space paste this address of the code folder because this command is used to change the current directory to the code folder's path. After changing the path, we need to write another command, that is python space app.py. By writing this command, it will execute the Python script and perform a runtime check for any syntax errors or logical issues. And then clicking the enter button, the app.py file will run. The Flask framework will host the application locally at the default address as of like this, and we need to copy this local link and paste this link on any web browser based on our choice. And I'm opening the Microsoft Edge and paste this local link and then click on enter button, and here the home page of this project, and we can see that home button, sign up button too, and click on the sign up button. Here it redirected to this register page containing of the details within it. It are very mandatory to create an account, but I'm having an account, that's why I'm using the sign in page to log in it and with an username and password as of admin, and then click on sign in button. By this, it redirected to this page called index page containing of the various columns within it, and we need to enter the columns with our attributes as of name. My name is Regna and age of 21, and gender as of female for 0 and male for 1, and constrictive percentage of 1 to 1.2, and the person's maximum heart rate received as of 98, and old peak of 47, and the calcium of 220.2, and the thalassemia of 222.2. And then click on submit button to predict the heart disease. After clicking the submit button, we get an result page where you have a chance of having the heart disease, and the probability of having the disease is of 34%. And this way we can predict the heart disease by using the various machine learning algorithms. And in conclusion, the project presents this nodal framework specifically designed for early and accurate prediction of cardiovascular disease. The framework is composed of 4 major phases addressing width of replacement technique and of feature selection techniques, and of the ensemble techniques too, width of decision tree, random forest, k nearest neighbor, logistic regression. The comparator analysis confirms the superiority over the existing methods, making it reliable and promising framework for early cardiovascular disease diagnosis in the real-world settings. Ongoing evaluation with various hospitals will further validate its applicability and real-time patient assessments.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.